So, hello everyone, welcome back to our prompt engineering series. So far, we have explored how to craft powerful prompts, and from basic instructions to advanced chain of thought and tree of thought. But let me honest, AI isn't always perfect. Sometimes, despite our best efforts, prompt fails. So today we are tackling that uncomfortable but a crucial truth about prompt failures. Before that, let's break down the title for us. That is prompt failures. That means we are acknowledging that AI outputs aren't always perfect. We are trying to understand when and why they go wrong, and that is very essential for our use. Next, hallucination means this refers to an most common and often issue where AI confidently generates the information, but that is an incorrect or nonsensical information. Next, injection. This highlights the critical security. That means whenever we get a malicious input which can hijack this AI's intent behavior, that comes under injection. And next, uh, just a second. Yeah. Next, we are talking about mitigation. So, this is all about practical strategies and techniques we can employ to prevent or detect these failures or even to correct these failures. So let's have dive in the into common issues like hallucinations and prompt injections, and understand why they happen, and most importantly, from this video, learn how to debug and how to secure and how to refine our prompts for more reliable AI interactions. Moving on, yeah, I would like to talk about the reality of our prompt failures, why this happens, and what are the types of failures. Let address few them, which is a fundamental reality that AI isn't perfect. So first the point is AI is a tool, not an oracle. So it's crucial to remember that LLMs, large language models, are incredibly powerful pattern matchers. But they are not being with their perfect knowledge. They can also make mistakes, even facts, or even they can also be manipulated. That is the first thing. Next thing is garbage in and garbage out. This means here old computing have holds the true of LLMs, but the quality of the AI's output is heavily depend on this clarity of the input prompt which we provide. So poorly constructed prompts will always lead to an poor and incorrect results. As we know, LLMs are pre-trained; they have a pre-knowledge for sure. So getting that information using our prompt. Our prompt should be a quality. Next is evolving threat landscape. As LLMs become more sophisticated and integrated into various systems, understanding their vulnerabilities like these prompt injection becomes very absolutely essential for secure and responsible deployment. And why it matters, see, for everyone working with AI, recognizing and effectively addressing these prompt failures, that becomes a key in building reliable AI applications. If we address these prompt failures, it makes to ensure it, I mean we are making it to ensure the data integrity, ultimately maintaining that user trust, so that we can create a trust with an AI systems. Let's talk or let's be in detail. First failure is hallucination. What is this one? See, when LLM generate information which is incorrect or not with our sense, or which is apart from its training data. I mean the provided content or context which is apart from its training data. Yet it present it has it were true. This is known as hallucination. Let's for suppose if you give a prompt like asking a biography for non-exist person, we don't doesn't have that person in our own, but still confidently AI gives something about that person confidently. Here the confident lie, that is hallucination. Why this is happening? Why is AI makes such mistakes? Because the first thing is lack of factual grounding. The model which give priority in generating this text over accuracy. Here instead of that one, it is focusing on statistical patterns. Next is overconfidence. Yes, LLMs don't know that they were wrong. They are predicting the next most probable token based on the patterns which they have, what they have learned. Even though those patterns lead to some misinformation, means uh, there are lack of the understanding, or there is lack of self awareness of what is the correct information, that dominates the overconfidence. Next thing is training data bias, means gaps or inconsistency in training data, which can lead the model to fill the blanks which are incorrectly. So it's if it's never seen a specific fact, it might invent it. That is a problem here. So let's start with these common and frustrating prompt failures, and we will move to why this happens. Okay, because due to this model's fundamental design, its pattern matcher, and based on some statistical relationships, which is it is learned during its training, even if that means facts which are lack of information also. So LLMs don't know that they are wrong. These are the few reasons for why prompts are failing. Simply why AI is facing a failure. Moving on, let's have a discussion on this prompt injection. This means security, where there is misinformation or malicious information uses to change the prompt which we designed, that overrides the LLM's initial system instructions, which cause the AI to behave with some harmful ways. For suppose a chatbot told always to be polite, that we included in our prompt, it might be replaced with ignore politeness or insult the user with the system instructions. That is what here happening. That is hijacked here. Next question is how you will differ this from hallucination. Hallucination is about like making AI making up with facts, whereas injection is about a user forcing the AI to ignore specific rules. So here the it is a critical security concern, I can say. So then how it works is the LLM's core function is to follow instructions, right? Next, injection is making the something overriding the instructions. Injection is overriding instructions within what that appears to a normal user input. Means injection is making tricking the model into give prior making telling it that give priority to other which the instructions which are lie, or we can say it is giving a priority to the commands over its original system prompt. So this is where the injection means. Moving on to the next slide, identifying prompts, what else do they fall? Here identifying these common pitfalls, or I can term it as an contextual errors in our prompt design. This may lead to an incorrect LLM outputs. That may lead to often miscommunication between the user and LLM's interpretation. So beyond these hallucinations and injection, the prompt may also have failures from simpler and more common issues, which are called prompt pitfalls. These are structured, or we can call it as a contextual errors also. Here I have mentioned few. First thing is ambiguity. So this happens when our prompt can be interrupted in multiple ways, like asking about banks without specifying that it is a river bank or a financial bank. Yes, some kind of human sense is needed in this prompting design. And the AI may pick incorrect interruption, or it may give a misinformation. Then the topic is going to be an irrelevant and get off topic responses. There is ambiguity. Vagueness. If you don't provide enough details or specific constraints, then the AI is left to guess. In that guessing, it may choose whatever it comes or whatever it has learned in the pattern matching, that is in training data. That also may leads to irrelevant outputs. But that irrelevance or what we don't want that one. Because why this is happening is, if we don't provide a specific details, it will take as a default values to give a response. Next, overload. Yes, giving AI too many instructions also, they may also cause a conflict. Like giving unnecessary information may confuse these LLMs. So it might struggle to it. I mean, it don't know how which one to give a priority. So it simply failed to follow all directions, and this also may give an irrelevant responses for us. Next one is context window limits, that we have discussed about this one in our previous videos about context window, where LLMs have a finite memory. If we give in our prompt AI generated responses we have, and that exceeds the limit, then the older parts of the prompt are silently cut off. So this causes the AI also to forget the crucial informations or instructions what we gave before. This also leads to an unexpected failures, where losing the track of our conversations with AI. So these are the few pitfalls apart from this hallucination injection. Mm, yeah. So debugging these prompts, which is an iterative process we have. It's not, we don't have any systematically identifying the specific failure mode. Just we have to refine our prompt to address a particular issue. Okay. That can help being a detective for an AI thinking process. We feel like a detective. Next, in prompting, we are moving with, yeah, debugging some prompts. That is an iterative process here. What is debugging the prompts? Generally, we have a systematic process of identifying these, analyzing, and resolving issues in prompt design that will improve LLM's performance, which have been seen in previous videos. Here, how to fix these failures? We engage in prompt debugging and a systematic process of identifying and resolving the issues in prompt design. So this transforms our initial outputs into desired results through continuous refinement. Okay, what is that one is ICE framework. What is this framework? I stands for intent, C stands for clarity, E stands for evaluation. Evaluation, I mean. So before you even touch the prompt, clarify your exact goal. What do you truly want that AI to achieve with this prompt? Reevaluating your own need is the first step to a better prompt engineer. And also ensure that you're solving the right problem. That stands for intention. Our Intention is important. We should have a clarity, right? Next about clarity. If our intention is clear, focus on making a prompt itself concise and complete. So this is where you will refining. Means we are adding a necessary context. This context will include those powerful examples to eliminate any misinterruptions by LLM. Along with intention, clarity is important. Next is evaluation. Finally, evaluate the output. Does it meet our intention and all our criteria? Analyze the AI's response to identify the specific errors, inconsistencies, what are there, and what are the areas where it fell or short against our defined goals. We have to identify that one. So follow this framework, ICE framework for iteration. So it is an provide which is an very structured and it can term it as an scientific approach to prompt engineering. It moves beyond simple trial and error to a systematic improvement cycle, which understanding both your needs and AI behavior. Yeah. Moving on with a small example, prompt refinement, bad to better. Just have this an example. Initial bad prompt, what we are giving. Write about climate change. So that is the first prompt. In the next iteration, we are making that prompt to explain climate change to a 10 years old. Here we are specifying the context. What is our context? We want to explain to a 10 years old. Next, in iteration 2, we are giving us act as a friendly science teacher. Explain climate change to a 10 years old. So using simple analogies in 3 bullet points. If you observe here, what is happening? Initially, it may give output as a generic, like Wikipedia kind of output. In the first iteration, it will give some simpler but may still have some generic kind of explanation, which the 10-year old will understand. In the next thing, it will concise, engage, and provide a rich output in only 3 bullet points. So, maintaining our context, clarity, and our intention is important here. So, by iterating these, adding context and persona and format constraints, we are guiding the AI to have highly specific and useful response. So this is the power of an iteration. Bad. So we are moving bad to better prompts. We have to always here secure better prompts. For that, we have mitigation and refinement. This prompt refinement, this involves continually optimizing our prompt design through this iterative testing and applying our whatever established best practices to achieve our desired output and which have a quality. So these are the general guidelines that apply across various prompt types and models for proactive quality improvement. So let's talk about these some proactive strategies to mitigate failures before they even happen also. Be specific. First thing is we always need to provide a clear instructions. There should be a no language mistakes also. And the prompt should be in precise manner so that the better the AI can understand and fulfill our request. Clear delimiters. Yes, use the delimiters for our structures. When we want our LLM output to be in a format structure, mention that in a tags or triple quotes also, which will clearly separate the different sections of your prompt. This helps LLMs to parse complex prompts also, and it will prevent confusion for it. Next we have is input validation and sanitization. See, for developers, it is very crucial here. Before sending any user input to the LLM, we should clear it by removing or escaping these potential characters or keywords, because this adds a layer of defense. I mean, preventing harmful code. Next, principle of least privilege, a fundamental security concept. Only give the LLM access to the tools, data, and some capabilities which it needs to complete the task, limits its abilities to perform the action, so that there will be a minimizing attack surface. Next, red teaming. Yes, finally be proactive. Actively try to break your own prompts and systems by attempting various injection attacks. So this continuous adversarial testing will helps to identify the what are the vulnerabilities, and before we are getting into an wild responses from LLM. Why? Because new attack vectors are always being discovered. So it is required to have continuous updates to our defense strategy also. So prompt injection is an ongoing challenge. There is no single solution, and it's often a constant. I mean, I can say it's like a cat and a mouse game between those who trying to exploit LLMs and those who are trying to secure them. So that's why keep in mind of all these strategies. Yeah. Moving on with advanced mitigation, what are these things? For production of these AI systems, we will need continuous monitoring, and we involves tracking of this LLM's performance and output quality in real time, right? While in feedback, we'll get a systematical user evaluations. We need a complete user evaluations to refine the prompts and models over time also. So here we have a few things to discuss to make track of this LLM's performance and output quality in real time. Human in loop. Yes, this involves integrating human oversight and correction directly into AI workflows. Human reviews is important for AI outputs, which provide a feedback on errors and what are the areas of improvement. And these corrections can feed back into refining the prompt or even fine tuning the underlying models also. Next, A by B testing prompts. For these prompts are for optimizing the performance. See, you can deploy multiple versions of prompt simultaneously to different user groups. So, by comparing their performance based on defined metrics like user satisfaction or a task completion rate, from these you can make a data-driven decisions about which prompt is most effective. That is termed as an A by B testing prompts. Next, we have automated evaluation metrics. Yes, beyond our human review, we can use programmatic methods also for summarizing or for keyword checking the keywords, which automatically accepts the LLM's output quality. This also enables our large scale evaluation, and this is specially taken care of when we have a repetitive tasks. Okay, automated evaluation metrics. In high level, it will be useful. Next is prompt versioning. Just like code, prompt should be versioned. Yes, using systems like Git to track the changes, revert to our previous versions, and collaborate on prompt development, which ensures our the systematic iteration, especially when we are in a team environments. So these extend our beyond of initial prompt creation to ongoing or operational excellence. So adapting these involves of course a challenges, but it will ensure your AI systems remains reliable with you using these techniques. And finally, yes, we to wrap up, remember these key takes, that is prompt failures, whether they are hallucinations or injection attempts. And they are reality of working with LLMs. Just understand why they happen in the first crucial step towards this mitigating them. Always use structured debugging frameworks like ICE. Why to use? Because to refine our prompts systematically, moving from bad to better prompts, which are and they should have a precise content only. Next, employ security measures, and especially clearing these delimiters and input validation, which will guard our against prompt injections. This will ultimately prompt engineering is an uh, journey of continuous learning and refinement only. So your AI interactions are truly only as good as your prompts. If you found this session valuable, you please comment and follow for more videos on our this series. Thank you. This is Charana, AI engineer at Data Valley, wrapping up. See you next time. Bye.